Hello everyone. In this video, we are going to explore a new function in LuBan. It is mesh Boolean operations. Let's open LuBan software. Firstly, mesh Boolean operates on two or more mesh objects. So in the first step, let's create a few simple objects using file create 3D shape. This is a prism, and I can set the z-axis to 20. 20 is, let's use another one. I'll set this to 100. Set the diameter to 50. Okay, this is our first object, and I'll click new. So we have a separate window to save the pyramid object. And then I'm going to create a sphere with 20 sides. Okay. A Boolean operator, which is under mesh Boolean, requires that the several mesh objects be located in one window. Therefore, you have to use file merge. Click the first one, yes. Click the second one, yes. And merge them into one window. Sometimes if you have an STL or a model that has disconnected parts, and you want to use Boolean to get a union of all these meshes, you have to do mesh separate all the disconnected parts as individual STL, and then use batch load all the part files, followed by batch merge. Currently, merge is disabled because we only have one file. When you merge a batch of STLs, they will be all in one window. It will look like just as your original STL, but the difference is that now LuBan can recognize these mesh objects as individual objects. And then you can use mesh Boolean to operate on them. I don't need this single mesh object, so I'm going to close the windows. Now I have the window that contains two mesh objects. You can position the relative location of these mesh objects by object transform. And you can see which is which by clicking object select. Keyboard shortcut is J. If I click J, I'll see the first object is the pyramid. The second one is the sphere. Okay, I press J again. I'll go back to the deselected mode. In the transform function, you can select which object to transform. The first object is the pyramid. The second object is the sphere. I'll move the sphere up a little bit. I'll move it up by 60, maybe 50. After I change a value in the text box, I hit the Enter key to update the display. Okay, now it's ready. We are ready to apply the mesh Boolean function on two mesh objects. When I click mesh Boolean, I'm given 4 different options. We can do a union, and in the section A minus B or B minus A. Here A and B refers to the first and the second mesh objects. So let's do a union. Mesh Boolean operator is a very time-consuming operation. LuBan has 3 different versions on Windows, Linux, and Macintosh. I've tested the 3 versions, and I have found that on Linux and Macintosh, this function runs much faster than on Windows, which is unfortunately just a fact. So on Windows, it takes quite a while to get it done. Also, if your if the two mesh objects has relatively complex intersection, it will take a long time to process. And if one of the mesh object is complex, the other mesh object is very simple, it may not take that long. Okay. By the way, on Windows, we can press Ctrl Shift Escape key at the same time to bring up the task manager, and we can see the memory and CPU consumption of LuBan while it is processing. It takes about 50 meg memory, so memory-wise, it's very little because our mesh objects loaded are quite simple. CPU is fully used. Still calculating. Okay, looks like it's done. It should have generated a new window. When the new window is generated, while we are playing with the different windows, it goes to the back, so you have to bring it forward. And if you use the clip tool, mouse clip tool, to clip into the mesh object, you'll see it's now a union of the two. Okay, I can disable the mesh, disable the edge. You can view the generated object in different ways. And obviously, you can use file export to export the object in different formats. So that is mesh union. To give you another example, say if I move the sphere up by 120, maybe a little bit 100, you will see that now we only have one intersection. I believe in this case the calculation will be a lot faster. So let's do Boolean, and we can do so A is the pyramid, B is the sphere. I want to use B minus A, do a B minus A, okay? And it's calculating. Memory consumption is okay, only 40 megabytes, and it's calculating the results. If you use a mesh that is about 10 or 20 megabytes, usually you have to wait for quite a long time for the process to come back. And I have tested on my computer. I waited for 10 or more minutes for the process to come back. This is the results of subtraction. The sphere subtracting the pyramid. And this is what we get. Okay, sphere subtracting the pyramid. There are many different applications of mesh Boolean operator. And one of the useful operation and one of the most frequently asked question is, can LuBan be used to make a mode? Make a mode. The answer is yes. So let's load an STL model and use mesh LuBan method cocoon to make a mode. I'm going to enlarge the object to 6 millimeter in the Z direction, and the cocoon has a clearance of 10. Save the model. This is only the first step of making a mode. Save the model to our desktop. Then I'll open the saved cocoon model. The cocoon model is merely adding a box or a cylinder, depending on the shape that you select, around the original object. And the original object is flipped in surface normal so that you can see it's an inner surface. Okay, that's the first step of making a mode. Before we have the mesh Boolean operator, I recommend our users to insert some drain hole using other software such as Mesh Mixer or 3D Builder. Now you can insert the drain hole using LuBan software. I'll go to File, Create 3D Shape, and insert a cylinder, a prism, something like this, to work as a drain hole, maybe 10 millimeter in diameter and 30 millimeter in height. 30 minutes. Then I'll File, Merge, or Control M. Select the first one, select the second one. This is the merged results. The cylinder might be inside. The cylinder is inside the cube, and it's quite big. In your experiment, you might have to reduce the size a little bit, but I'm just going to carry on to give you an example. I'll close the original STL and close the cylinder. I only need the combined model. As you can see on this screen, there are 3 distinctive objects: the box, the cowl, and the cylinder. But for LuBan, it only recognizes as 2 objects because the box and the cowl were from the same STL model. Even though they are disconnected, LuBan sees this as 1 object, and it sees the cylinder as another object. So this window contains 2 objects in the eyes of LuBan. And I'm going to adjust the positions of the cylinder and the cowl. The cylinder is the first object, and the cowl is the second object. I'm going to move it up and try to move to the head region of the cowl. 100 is too big. 60. Yeah, okay, 60. Maybe 50. And then I will move it in the X direction by 20. 20 is a bit too big. 15. And this is the trial and error process. And I'll move it up a bit more. Then move in the Y direction. Move by 20 or 15. Yeah, this is just about right. Okay, it's in the middle region of the cowl. A good position to use as a drain hole. I think X we can adjust a little bit more. 7 or 6. Yeah, 6 is roughly at the center. Okay, this is our drain hole. So I'm going to use the mesh Boolean. That's the first object. This is the second object. So mesh A, mesh B. We want to do a mesh B minus A. So the cocoon will have a drain hole on top of the cowl. B minus A. And click OK. It will take a while to process because the cowl is of relatively complex shape. And I open the task manager just to monitor the progress of LuBan. So memory consumption 70 meg and CPU is fully used. If you process bigger meshes in file size, you will find that the CPU consumption of LuBan is above 50% of CPU. On my computer, I have 4 cores, so that means, it's done. So that means the process is multi-thread. This is the generated results. As you can see, there is a hole generated. And if I use the clipping tool to clip inside, you can see there is a beautiful drain hole generated on the cocoon model. If you want to make a proper mode, you need another drain hole usually. One for letting in the liquid, the other one for letting out the air in the hole. So let's close this one. And again, the last step of making apologies. The last step in making a mold is to cut the mold in half. Okay, that's roughly right. Okay, the parameter is roughly right. I'm using planar cut, and this is the plane equation. It will cut it in half. I do not want regional cut. Cut chamfer should be 0. There is no gap on the edge. I want a close cut, no natural cut. Part number, I don't want any part number. And plug, I'm just using the default value, tolerance, a negative 0.2. Okay, and hit cut. Save it on the desktop. Okay, it's done. And if I use the keyboard shortcut E, explode, I will see what the mold look like. Okay, it's a drain hole. The drain hole is probably too big, but it serves to give an example, and you can create several drain holes. That is all for this video. I hope you will enjoy the mesh Boolean function, and you will find many applications for this function. Thank you for your attention. See you next time.